Part 5, Graphing Quadratic Functions. Identify the vertex, axis of symmetry, and intercepts for the function f of x equals 2x squared minus 4x minus 1. Let's start with the y-intercept because that's usually the easiest. For the y-intercept, that means when x is 0, what is y? So if x is 0, then f of 0 is 2 times 0 squared minus 4 times 0 minus 1, which is negative 1. So our y-intercept is the point 0, negative 1. To find the x-intercepts, we need to either factor or use the quadratic formula. So let's go ahead and use the quadratic formula. So x equals negative b, so negative 4, which is 4, plus or minus the square root of b squared, which is 16, minus 4 times 2 times negative 1, all over 2a, so 2 times 2. And hopefully you have the quadratic formula memorized now and you can do this fairly quickly. We have 4 plus or minus the square root of 16 plus 8, which is 24 over 4. And if we simplify that square root, we have 4 plus or minus, that would be 2 square root of 6 over 4. Divide every term by 4, and we get 2 plus or minus square root of 6 over 2. So those are our two x-intercepts, 2 plus square root of 6 over 2 and 2 minus square root of 6 over 2. We also need to find the vertex and the axis of symmetry. So to do that, to find the x-coordinate of our vertex and to find the axis of symmetry, we do negative b over 2a. So negative 4 over 2 times 2, which is 1. So our axis of symmetry is x equals 1. And to find the y-coordinate of the vertex, we find f of 1. So 2 times 1 squared minus 4 times 1 minus 1, which is 2 minus 4 minus 1, or negative 3. So our vertex is the point 1, negative 3. Now let's graph this. So using all the information that we already have, we found that the y-intercept is negative 1. We found that the x-intercepts are, well, one is 2 plus square root of 6 over 2, which is about 2.2. And the other x-intercept ends up being about negative 0.2. Our vertex is the point 1, negative 3. And our axis of symmetry is that line x equals 1. So that cuts it in half. If I look at this, my axis of symmetry means that we have a point the same distance on each side of that. So we have another point. If the y-intercept is 1 to the left of the axis of symmetry, then we have another point here that's 1 to the right. And that's probably enough to graph. We have the vertex and we have a couple points on each side. We have the intercepts. That gives us a pretty good graph of this quadratic function.